Hello and welcome back to this Java Reflection API mini-series, where we are covering basics of Java Reflection API and building interesting projects, like JSON Mapper, where we convert our classes into JSON representation, Annotation-based validation engine, where we put annotations on our class fields and execute some validation rules, and Spring-like dependency injection, where we can cover automatically injecting our dependencies between our classes. If you're not aware or are interested in these topics, please watch previous videos. And today let's build one more interesting project that will sharpen our skills in the Reflection API. And that will be our own unit testing framework. Unit testing framework is a perfect candidate. Why? Because what it really does, it scans our class path for classes that have methods with some test annotation. Then it collects them, executes them, and reports our results. I think with the things that we have already covered, it should be quite straightforward for you. But let's do that together. Okay, and for this demo purposes, we will have a simple calculator class that has some basic operations like addition, subtraction, multiplication, and division. Nothing too fancy. Then for this class, we have also defined our tests. So for each of the functionalities, at least one. Let's actually maybe break one. So we would see the response that, okay, this test has failed. And we want to add our unit test framework as a dependency here. So everything will be located in this JUnit core. We will have all the unit testing framework logic there. And it will be in scope test. So this is only a test dependency. And of course, if you look at this module right now, it's empty. There's pretty much nothing. And our goal is to implement it. And the obvious starting point would be introducing our own test annotation. We want to have it to be retained during the runtime because that's the moment where we will scan our code, and the target should be only applicable to methods because we are looking for test methods. So now we want to use this annotation in our unit test and mark all of these methods with our test annotation that we just created. So this is not a JUnit one, it is our custom-made test annotation. So basically step one now is done. Now we need to scan the class path and try to find all the classes that has at least one test defined, because that's the things that we need to execute. We already did something similar in the dependency injection case, that we would like to scan the class path for the resources that are matching some annotations. Pretty much we need to repeat the similar steps here. So let's create a function that will return a list of classes that we will call scan for tests. And we will provide some sort of root package where we want to start, because I could imagine that not all packages are the ones that we need to run the tests in. So first of all, we need to access our class path. We can do that in multiple ways. Let's do through current thread, again, get context class loader, and also let's return null for now, so we have no compilation errors. We are always operating in Java with packages. Packages are this notation that we have some names, path, are separated by the dot. But when we are using the class path, those are resources, those are files. So we need to provide a path there. So let's now convert our root package to path, replacing all dots that we have with slashes. And now let's try to access this resource using our class path, get resource, and let's provide this path. And now let's output this resource to see if we have found it. To do that, we need actually some sort of class that will have main, and that will be actually executed when we will launch our tests. So that will be one particular class that will start the process. I will call it JUnit. Okay, and here we need to create main, and we get the compact file API, and that's a Java 25 feature. If you want to see more details about Java 25, let me know. I will make a video with a quick summary. I would like to keep it, but let's not confuse people maybe that are not yet aware of it and have ordinary signature. I will just create a test scanner class here without any other abstraction. And I would like to scan for tests. I will provide here this higher level package. Okay, let's now run it. And we see indeed that there is one file, actually one directory that is matching our package. So we have successfully found the resource. But there is one little note. So if you look at this is the path to our core, not the project that we are trying to get the tests working for. And that's because adding the dependency is not really enough. We need to do a couple of more steps there to have proper linkage. But let's keep that for later and now focus on the functionality. So in order to have some sort of test where we can play around, I will have here an example package, one more example test class, where I will have some sort of function marked by the test, just that we have something to scan also in this project. Now, okay, now that we know that this resource is a directory, we would need to work with it. So let's create a directory reference through file abstraction right now. And resource get file. We're using file abstraction because we know that this is a file, actually a directory, which could hold another directories or another files. So let's list what files are located there using the list files function and go over one by one and see what's inside. So for each file in files, let's for now just output. And we see that, okay, starting from this level, we took the directory, this base package, and inside there was one more file which was called JUnit, which is another package. Okay, now that we know that there could be more directories inside, we just can check if it's a directory, and if it is, we can actually just call this function recursively. We could make more things more robust, but let's keep things simple. Let's just call ourselves by providing root package and adding the directory name. Now let's run it again and hope to see more results. And indeed we do. So now we have recursively gone deeper into all of the packages that are inside our base package. So starting with JUnit, it found that there were annotations inside, so it went deeper, found test class, then it went back and found our unit class, then there was this example, then this class, scanner, and the class. Okay, so far so good. Now we know that we have else a case, that there could be a file, and actually we are interested in the files that are ending with the class, because there could be also resources, property files, anything else. So, but we are looking only for test classes. We need to inspect it with a reflection to understand if there is at least one method annotated with test annotation. So for that, we need to construct a class name. So it consists from our root package. We need to add the dot. Now we need the file name, but file name will end with dot class. So we need to remove this dot class. Okay, and let's just for the tests output the class name and see if we have correctly transformed it. Indeed, now we can see that it looks like more Java package type what we use in the imports. Why we need this format? Because now we can use reflection to actually get the test class using class for name and provide this class name. So now we will try to load this class from our class loader. And here it can throw an exception, so we would like to have some sort of try catch around, and we would like to handle it, but ideally if there is some problem with this class, we just don't load it and skip it. So for now, let's do nothing. The only thing maybe we can do to leave the stack trace in case we now have some issues while developing it. Okay, and now I would like to have a helper function defined that would accept a class and return all of the methods that has test annotation to them. So let's find list of methods called list tests, and we will give a class to look into. So we need to import it from the reflection. And you remember with reflection, you can easily find the list of methods. So we can just say test class, get declared methods. Let's convert it to stream using array stream, because we are only interested in those which are annotated with test annotation. And let's collect those to list and return the result. So if you remember, the method abstraction had this annotated element interface at some point, which has isAnnotation present method that can be used. The same thing was on fields, on constructors, on classes. They all implemented this annotated field element. And here we would like to filter only for those which has them. Now that we have this method here, we can find our tests by asking list tests and providing this test class. And if it's not empty, we know that there should be at least one test defined, and we need to return it as a result. Let's here somewhere define a test classes that will be just a new array list of type class. And here, as we know that it should be included, we just add this test class to the list. If not, we just ignore it. Okay, now instead of this null, we need to return our test classes. And one more thing, remember that recursive scan, we will find more classes here. So we would also need to add them to our test classes if found. So add all that was inside this list. Okay, now if I will go back to the JUnit, and now let's collect our test classes and output them to the console. Let's run it, and we expect to get 1. We have all logs that we can actually remove the file, so it doesn't confuse. Let's rerun it. And we indeed have 1, which is this example test class. So it means that we have completed step 2. We have found all classes that contains at least 1 test method. Okay, and now step 3 is actually running these tests. So we know the classes, and we would like to go over one by one test class inside these test classes. And we already had a function that could find the tests inside it. Yes, we are doing actually double work, but let's not worry about that. So let's ask test scanner to list the tests of this test class. And now let's create another package that we will call runner and include there our test runner. It will have one method. Currently, let's leave it as void. Run test. We will provide a class and a method to execute. So this is the class that will be actually responsible for creating our instances, invoking the method, and gathering the results. So let's quickly add it to our flow. Test runner, new test runner. And here we would like to go over each test in these tests. And using test runner, let's run the test. Okay, looks good. So our goal is to create an instance of this class to execute this method on. So let's create this test instance, which we could do using the test class get constructor and call new instance on it. So this could throw exception, of course. Let's round it with try catch, and there are many reasons why it could fail. But I'm not really interested in any of them. I just want to have this generic exception and just say that if something went wrong during this text execution, it means test failed. So either it was a real failure or misconfiguration. Let's play a blame game and say, developer, it's you to fix because it is my framework. And if we are not working together, it's your responsibility. Wow, what an awful thing to say. So let's output here test failed. Now that we have our test instance, let's invoke our test. So test, invoke, and provide our test instance. And for debugging purposes, let's add some logs. So running and provide this test. And here we can say that it passed for now, because no exception were thrown. Remember, when we are doing the assertions, it's just throwing an exception, which is catched by the framework. So here, and the test failed, and let's also output the test itself. Okay. So now if we go to the JUnit and run it, we should see a passing test. So, okay, we are running this test, something happened, but we are currently not doing anything there, and it passed. Let's add something for our test actually to make sense. So for example, let's start with the log running some logic. Let's just throw one exception. New runtime exception, result is not matching. Right, just to indicate that this test has failed. Let's rerun it. Okay, so you can see indeed running our test method, then we see our output from it, and we see that this test failed because we have thrown an exception here. Looks good. Let's add one more test just to see if it also would be detected. And here let's not throw any other exception and just add something to differentiate the log. And we can see, okay, running some logic, test failed, running the second one, running sim logic 2, it passed. So there are 2 tests executed. And with this test runner, we have achieved our goal of executing tests. It means we are going to the step 4 and we need to provide this information to the user. We need to output the results of our tests. So we have found tests, we have created instances, we have executed them, and now we need to gather results and report to user. But for that, we need some sort of structure that will contain our responses. And here we could just create a record, filling out all the fields and having a flag, did this test pass or not. But here I would like to go a different approach and work a bit with the sealed interfaces. And I will show you why in a minute. So let's start by creating an interface for our results. So test result. And what we want to store there. We want to store the class, the test class. We want to store the method, the test itself. There are functions, sorry. And I would like to also store duration, like basic wall time would be enough for me to see how long did it take for the test, to find which are the slow tests. And it would, of course, be totally understandable if we have a flag here is passed, but I, like I said, want to go with a different approach. So let's create an record here called test passed, which will implement our test result. And here we need to list all of the same elements. So there will be a test class, there will be a method, test, and the duration. Okay, now here I will go and do the same thing with test failed. I will just copy over those elements here and say that it implements the test result. But here will be one difference. I will add a throwable, which will be the cause of the failure. And now we have two separate structures for it. So if the test was passed, we have basic fields, but if it was failed, I will have additional field that will be called cause. I know these for now are the only implementation, so I would like to say that this interface is sealed, which means that I do not allow to implement it by any other implementation. But I will say that it permits two implementations right now. First one is this test passed, and second one is test failed. These are the only two implementations that I currently permit. I'm saying now to the compiler, these are only two interface implementations that I allow. So here now, when we are running the test, I can now return the test result. Now here, let's remove this output so that we don't have long debug statements and just say, okay, if everything here is fine, we return that this test has passed. So we need to provide test class, we need to provide test method, and actually the duration, which we did not calculate yet. So let's measure the start time and keep it in the milliseconds. And here just put then the system current time millis minus the start time. Okay, now we have the duration also. And here in the exception case, let's return that this was a failure. Same class, same method, same duration. But now I want to have a cause of this exception. Why I'm not here setting the original exception? This is because it is wrapped inside our reflection call. There is a method that will call and also capture our exception and rethrow it. So it will add one more step in the stack trace. So I'm only interested in the reason why it was thrown in initially. I don't want this wrapper around. So that's why I'm using the cause. Okay, so now we return some results. Let's go to our main function that is executing everything. And here, let's collect the results as some sort of list. We could have some sort of abstraction or map, but let's keep again things simple. So it is just some test result list. And here, let's add our return from this function. And now let's, instead of these test classes, let's output the results and verify if everything there seems correct. Okay, so I see that there is one test failed. It is an test located in the example test class, which is called test1. Duration was 2, there was a runtime exception, results did not match. Remember, the first test was failing. Then the second test passed, and you can see that also the duration was 0 milliseconds because it warmed up and it's pretty much did nothing there. Okay, so far so good. We have collected all of our results. Now we would like to actually output this to console and to some other reporters if needed. So let's create new abstraction here, reporter, and let's create now an interface, test reporter, because I would like to have multiple test reporters available. And the only goal of it is to report this list of test results somewhere where it's needed. Is it a console that we will implement first, or maybe generate a report file, or maybe send to some sort of endpoints indicating how often this test fails or not. The results. So like I said, let's create one first that will be just console reporter that will print some pretty output to the console when we are finished. So it will implement the test reporter. And now here, let's add it. Let's create actually maybe multiple reporters, list of reporters. Let's list them here. First, our reporter will be the console reporter. Console reporter. And at the end, when we have collected all results, I won't print it like that. I will say, okay, reporters, for each of you, execute the report on our results. Reporter. Okay, looks good. Now for the actual implementation. Okay, so first of all, I would like to have some sort of statistics, how many tests were executed, how many tests failed, what was the total duration, etc, etc. So let's collect that result. So first would be how many tests actually there were executed. So total tests it's matching basically the size of our results, because for each test there is at least one result. Then we would like to find failed tests. So for that, let's stream the results, and we would like to filter for the result that is instance of test failed. So we've tried to find all of those that are of instance test failed and just count them. Okay, what about for passing tests? Quite simple, we can just take the total and subtract the failed tests. Okay, what about the total duration? Again, we can take the stream of our elements. Let's map to long and ask the test results, please give us the duration. And we want to have a total sum of it. And now let's simply output everything to the console. So we had total and the number of tests, then failed, again, number of tests, and the duration in millis. We could also output the past tests. Yeah, let's do that just in case. And now let's provide them just as a formatting parameters. So total tests, then past tests, failed tests, and total duration. Okay, now if I will run my logic, we would see, okay, there were 2 total tests, 1 passed, 1 failed, total duration was 3 milliseconds. Okay, and now I would like to go over all the files, list all the methods, and show their status, did it pass or fail. Here I will define one helper function that will be just print class results, and provide here class and list of results that are for that class. So currently we do not have such information, like class and it separate the results. So we would need to group our results by the class. Let's take our results and stream them and use our collector, which is called collectors grouping by. Here we can say what is the key by which I should group, and it will accept an element here, and we say, okay, take the test class and use it as a grouping parameter. But you can see here actually there is a bit messed up of the logic, because this is not a class with the question mark, it is actually a capture of question mark. I will explicitly here provide the type. That's one place where the var is not quite well working yet. So let's add class here as our key and list of test result as our value. Okay, now let's do a bit reformatting. Okay, so we now have gathered that information. For each test class, I would like to execute here this print class results and provide from the test class key will be our class and test class value will be our list of results. This actually can be replaced with the simple for each, which would be much better that we have a key and a value extracted already, but I want to do before this transformation actually a stream and do a sorting. because I want to have the tests listed in alphabetic order always, so it's easier for me to locate them. So here I want to provide a comparator. There will be an entry, and I want to say entry get key get name. So now it will sort in natural order by the class name. Okay, looks good. And now for the print itself. So here actually we'll need to do some similar things because we want to have some sort of summary of each class. So we will repeat most likely these steps. I will just copy them over. So we have total tests, which will be result size, failed tests, how many passed tests, and total duration. And here we can also introduce did all tests pass flag. It will match if the total tests equals to pass tests. And now let's output our summary. So here printf. So first of all, I would like to have a status, did it pass or fail, then the name, then how many tests were passed from the total tests, and total duration in milliseconds of this class. And of course we want to have a new line here. So now if the all passed is true, I would like to output text pass, else I would like to output fail. Now we would like to have class name, so test class get name. Then we would like to have number of pass tests, so pass tests, and total tests here, total tests. And the last argument, the total duration. Okay, so now if I will run it again, we can see, okay, total, I forgot here, new line. But we can see that this file failed because there was only one test passing. But let's here in the total duration add a new line at the end. Okay, so now we have it for each of the files, and now we would like to have some sort of a bit summary below. And let's create a method for that. So print test result. And here we will provide just the test results. And here we want to invoke it by using the results for each, and let's call this print results. So just a method reference for this method. And here finally where the sealed interfaces will come into the play. Now instead of checking the flags, if it's passing, if it's failing, etc., I can just provide a switch and say let's switch on this result. Case it is a passed test, then I do following step, then I output one pattern. In other case, if it is the failing case, I output the failing pattern. And you can see now the switch no longer asks us for default case because we had sealed type. We only say that there could be only two possible implementations, and we have covered it with each of these cases. So now imagine we would like to have some tests to be ignored, and of course it will be a result of test ignored. And now we add one more implementation in the sealed interface, and it will be just another case here that we know that we need to handle it. And no longer a Boolean flag would help us because it's either passing or failing, but how we mark it, was it ignored? Another flag? No, we can just use the class itself. And let's keep it quite simple. So let's here add just that it pass. The test was named like that, and it took that many milliseconds. So let's add the result. We can use the past actually here. Test name, then past duration. Okay, looks good. And now here for the failed scenario, we can do quite similar things. So let's just maybe even copy over it. So instead of past, we can use the fail reference. And why that matters? Because now we can actually provide here one more thing, a reason. So here I can say failed, cause, and let's get a message of it. And this field is not located in this case. It's not accessible. We don't need that information there. So we can reduce our object size without this field. Okay, let's maybe have them formatted the same way. And it auto format still did its magic. Okay, anyway. Now let's run it and see. I forgot the tabs that I wanted. And actually here to put fail. Oops. Let's run it. And did it. Again, the new line. Always forgetting the new line. Okay, we can see there were total 2 tests, 1 passed, 1 failed, duration 3 milliseconds. Total, there was a failure of this class, which was only 1 successful with 3 milliseconds. So there is 1 passing test and 1 failing test with the exception message. And let's have a final touch. I would like to have some colors. So we can use special escape codes to add colors. For example, this one will change the text of the pass to have a green background. And this one will add a red background to the fail text. So if we now run it, now it outputted everything red, but because we outputted this text, I would like to leave it here like a badge, and then all other should be like a basics color. So we need to reset the configuration by just providing one more escape code, which is just setting it back to default one, and actually we need to do that in both scenarios. So let's rerun it. Okay, now we can see much better and clearer that this was a failing test. And I want to have something similar here. I would like to have this part to be green and this part to be red, but not like in background, but just the text color. So for that, we can go here again, find our output, and here the pass one would be 30. Instead of 42, I will put 32. Let's run and test, did I put it correctly? Yes, so it is now green, but we again need to reset it afterwards. So let's put 0 there. And for the fail, we'll have 31. And again, we need to have this reset at the end. Okay, now let's run it. Nice, looks good. Maybe for the passing one, it doesn't make sense. We can just end it after the pass text. But for the fail, I want to see it red. I want to quickly be able to find it, which is the failing one. Okay, looks good. Okay, now that we have finally working running, we would like to integrate it with some other projects. So I would like to have now this basically closed. And here in this calculator application, I have some logic that I would like to test with our testing framework. Okay, so first of all, we need to install our JUnit core artifact. So it should be available for our project to be downloaded as dependency. If we would run tests, and we actually can see already it here, so the demo one, it actually failed with the test already. So it is running the calculator test, that there were tests run, 1 failure error, skip, time lapsed, a failure, But we did not specify any testing frameworks. Well, actually there is this plugin, Surefire plugin, that is executing our tests by default, and it's trying to match the classes that are ending with test and contains test keywords inside the methods. And you can see also this information here that it was using the auto-detected provider, that it used JUnit free Surefire basically provider. So we could configure our own provider. So basically what it's saying, we have the test framework, we have this provider, and we could integrate it inside Maven during this test step. But that will be an overkill for now. Let's now keep things simple and just do a hacky workaround. So I will go to this POM of my project, the demo one, and I would like to actually skip the running of default testing. So now here in the build section, in the plugins, I would like to configure plugin called Apache Maven plugins, and not the side plugin, but the Maven Surefire plugin, which right now is I think 3.5.4 latest version, and provide one configuration. So I will here in the configuration provide that you should skip tests true. So what it should override now the basic and default logic. And now if I will take this unit demo and run the tests, so you can see it built successfully. And if we look, because the tests were skipped in the Surefire plugin. So we have disabled the default behavior. And now we would like to enable our own behavior. That is also done via plugin, which comes from the group ID of our codehouse mojo, not the animal sniffer parent, wow, what a name, but called exec-maven-plugin. This plugin is used to execute any Java class during any of the steps of the Maven lifecycle. And latest version for now, I think it's 3.10 for me. Okay, and now we need to configure what to execute and when. So let's provide the execution section. Execution. Let's give it an ID. I will call it JUnit. Then I will need to set the phase when to run it, and the phase will be test. It means that we will do it during the testing phase, basically at the end of the testing phase. Now here we provide again a configuration what to execute. And in our case, we want to provide a main class. Then we want to execute our main, which had all of the logic that was scanning the class path. It was called in the JUnit, the JUnit itself. And we need to do one more thing. We need to set that this is a test scoped plugin. So basically we're saying that it should include those classes that are generated during testing, because not all dependencies are packaged in the final release, but we want to have access to all of the testing ones, because our dependency was injected in the test scope. Okay, let's refresh those things. We forgot to actually provide the goals, and it should be Java goals. So it should be executed during not like a separate plugin, but a part of this lifecycle of Java project. Let's run the test one more time. And indeed, here are our results inside Maven. And we already see that it has catched up the class of the calculator test. It said that 3 of 4 has passed because we only configured 1 to fail, and we have a list of the failing and passing tests. But now you can see the build is green because it is not failing the build if we have one failing test. So let's quickly correct that. Let's go to our JUnit now here, and after finishing with the reporting and everything, we want to have again one more go over the results. Let's again stream them. And let's see if there is any failing one. So result, instance of, test failed. Now, if there is any, so we can just find any. And if it's present, we throw out new runtime exception. And we just can say that, okay, there was a test failure test. So now we terminate our main with some sort of exception. Okay, let's install our core library again. So we have the latest dependency and run the tests. And success, we can see that we have failed Maven build. And if you check the logs, build failure, there was an exception, test failure, and we can see here above everything that we need to know about this scenario. Okay, let's actually correct that test and see if we would now pass. So which test it was failing? It was failing the multiplication. So the multiplication, it should be 12. And let's rerun this build. And now build success because all tests have passed. Just for curiosity, let's create maybe a new file, new unit test, which should have some sort of different tests. Test, I don't know, uppercase of the string. So let's have value, for example, Edgar's. The expected one should be, and if the value uppercase equals the expected, but we say that it don't equal, then we throw an runtime exception, values does not match. Let's see if it will be picked up by our testing framework. And we can see it was indeed. So here is the second test suite and the test. Now let's break it. So the expected value was with the exclamation mark at the end, and build has failed because, of course, the values does not match. Okay, so far so good. One more thing that we probably need to do is to get rid of this hard-coded package. Right now we are telling that this unit framework is only working with our package, but we would like to provide it as a configurable option. So instead of here hard-coding it, I would like to pass it as an argument. And actually that can be done using the plugin that we are working with. So let's go to the demo one, and here you can see we had the main class configured and the class scope, and we also can provide here arguments. And here I will provide my argument by listing the root package I want to scan for. Now if I go back to the JUnit now, here it will be passed as a command line argument. So I can extract here the root package, but actually I need to check maybe it's not passed. So let's see if the length is larger than 0, basically meaning there is something, then we try to access the root package as we expect it to be as a first argument. If not, let's say that it will be just dot, meaning the top level folder scan everything. And let's here put this also. Okay, now let's install our dependencies, so the latest changes are picked up by the module, and run our tests. And we can see everything is okay, our tests got picked up. So that's one thing that we could access as a configuration. Another thing that we could do is list here what reporters to use, right? Another, like second, third, fourth argument could be the reporter list. We're just using the reflection, load the class, create an instance, and populate the reporters. And that way we allow users to create custom extensions for our little framework. And of course we could expand it with different kind of functionality that we would like to. It's just a matter of our imagination. For example, I would like to have some more details on the failing case. So I would have and want to print a little code snippet with some lines where the exception will get thrown. So when the test got failed, I would also like to print a test code snippet. There we need to provide here a class name, so failed test class get name, and the error line, which we can get from the failed cause. In the cause, there is actually a stack trace element, so we can get the stack trace. We are interested in first element, and let's get the line number. And some sort of context, how many lines you like to see, for example, 3 above, 3 below. So quick little function that I wrote in the background just to make things a bit more fun. You can find it in the GitHub if you like, but let's see it in action now. Let's again rebuild everything in the Maven. And we get this beautiful little snippet that is saying basically where the exception got thrown in the test. And as for today, I think that's enough. I think we have created quite interesting thing built with multiple steps, scanning the tests, running the tests, outputting the responses, failing, and integrating it in our projects. For now, let's stop, otherwise there are unlimited features that we could add, and it's not really about the topic of the reflection. But I leave it that for you. Try creating maybe an ignore option that we can mark a test for ignore, like adding a field on the test annotation, then not running that test, but don't forget to add that in the results by adding one more sealed interface implementation that you allow in the list. Or maybe an HTML test generation, so you can open the results in browser, not in the console. Or basic assertion function collection, it's up to you. But just do the practices, because this is the most important skill right now in the coding. And if you have ideas for any other frameworks you would like to see under the hood, how we could build, maybe not exactly, but with the tools that we have, leave that down in the comments. And of course, if you like such content, leave a like, subscribe so you don't miss the next one. But for now, keep coding, and I see you next time.